Hi, welcome to the video on slip and its significance of three-phase induction motor. So we need to understand first what is slip and what is the importance or significance of the slip in three-phase induction motor. So as we know, the induction motor works on the principle of mutual induction. That is, the EMF is responsible for producing the torque in the rotor and which is not been supplied externally like DC motor. So the stator supply produces a rotating magnetic field once the stator is been given with a power supply. The stator, which produces a rotating magnetic field, which we have already discussed about this rotating magnetic field in the previous video, where you can refer what is rotating magnetic field in three-phase induction motor. So this rotating magnetic field is produced once the stator is given with a three-phase supply. And this field will rotate at a synchronous speed, which is ns is equal to 120 f by p, where p determines the number of poles, and based on number of poles we can fix the speed of a induction motor. If poles is 2, ns is equal to 120 into 50 divided by 2, it is around 3000 rpm. Okay, as the pole changes, the speed also changes, which we have seen in this next this ns is equal to 120 f by p. So according to Lenz's law, the EMF induced in the rotor will produce a current to counter the source of change, which opposes the cause producing it basically. So the rotor starts chasing the rotating magnetic field and it will try to catch up the speed of the synchronous speed and rotate in the direction of the same as rotating magnetic field. So if the rotor reach the synchronous speed, that is rotor speed is defined as n, which is equal to ns, then the relative motion between the rotating field and rotor will be 0, and therefore no EMF will be induced in the rotor and rotor will slow down. So because of this above phenomena, the rotor speed n should be never be equal to ns. That means the rotor should never catch up the synchronous speed, which is equal to ns. Otherwise, the motor will stop rotating, and there should always be a speed of the motor which is less than the synchronous speed. There exists the difference. So there should be a relative difference in this speed. So then the rotor starts rotating in the direction of rotating magnetic field. So slip is defined as the difference between synchronous speed and the motor speed. So slip is an essential feature for proper working of an induction motor. So without slip, the motor cannot run. So the slip is generally measured in percentage, which is around 5 to 6% in large motors and 8 to 9% in small motors. The percentage of slip is given by ns minus n by ns into 100. So if you remove the 100, this will be a absolute slip. So absolute slip is s is equal to ns minus n by ns. So when the rotor is at standstill, so when you see when the rotor is at standstill, S is equal to 1. So the frequency of rotor current will be equal to supply frequency. Means when the motor is at standstill, at rest, slip is 1, then the frequency of the rotor current will be equal to the frequency of the supply, that is 50 hertz. So when there is a relative speed, the difference in the speed exists, then the rotor frequency will be very less comparatively to the frequency. So we need to have a relation between this rotor speed and the supply frequency, rotor frequency and the supply frequency. If n denotes the speed of the rotor and ns denotes the speed of the rotating magnetic field, and f denotes the frequency of the supply, and f dash denotes the frequency of rotor current, then the relative speed s is equal to 120 f dash by p, where f is the frequency of the rotor. So f is the frequency of the supply. So if you divide this equation 1 by 2, we get f dash by f is equal to ns minus n by ns. So please make a correction. This is ns. Therefore, which is equal to, this is determined as the slip, absolute slip. So f dash is equal to s into f. So the frequency of the rotor will be the, it will be equal to slip times the frequency of the supply. Thank you for watching this video.